everybody, Mrs. Bixler here, and we are going to start our first official unit of honors geometry. Whoop, whoop. So this first unit is called logic, and you'll see it's actually kind of unit 0 because we move on to unit 1 next, but we'll just call this our logic unit. And you probably know a lot of stuff about logic already, which is awesome. And we're going to kind of break it down and then do some pretty fun problems along the way. All right, so the first thing we're going to talk about are just conditional statements. And a conditional statement is one that you're probably really familiar with. It says, if something happens, then I know something else will happen. So here's a little cartoon for you to read. So funny. So this is a typical conditional statement. This is saying, if I had more money, then I could watch TV in a big house in the country as opposed to a medium-sized house in the suburbs. Cool. So it's saying, if I had money, then I could watch TV. That's a very typical conditional statement. So let's break this down into specific parts. So if I had more money would be our hypothesis, then I could watch TV, blah, 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 blah. That would be our conclusion. So our hypothesis, we kind of refer to this as P often, and our conclusion is Q. So if P, then Q. If I know P is going to happen, then Q is going to happen. So order, though, does not matter. The meaning does not change. So even if you flip things around, I still have P as my hypothesis and Q as my conclusion. So here's our typical one. So if P, then Q. But I also have P implies Q. And you'll see us use this a lot. P implies Q. Q only if P. So see how the if statement is still our P. So that's still our hypothesis. And then the second one, or the second to last one, is pretty similar. So Q if P. So again, that if is with my P. So even if it comes second, if it's if, blah, 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 then you know that that's still your hypothesis. And then the last one, this one's a little bit tricky. Q when P. So Q will happen. I can watch TV in the country, whatever it was, when I have enough money. So it's still, our hypothesis is still when I have enough money. And our conclusion is I can watch TV in a bigger house. So let's look at this cartoon. I'll give you a raise on one condition, Max, if you never ask for another one. So here's an example. If came second, but this is still our hypothesis. So if you never ask for another one, then I'll give you a raise. Okay, so let's look at this. So if Mrs. Bixler's hair is wet, then she showered this morning. So you come into school, you see that my hair is wet, then you can assume that I showered this morning. And here's an important thing. You always want to assume that the initial conditional statement is true. So I'm telling you that the initial conditional statement is this. If you see that my hair is wet, then I showered in the morning. Okay? So you're going to spend a lot of time confusing yourself if you're like, but you could have done, you're right. But this is fact, okay? So if my hair is wet, and I'm just going to abbreviate here, then I showered. Now, go ahead and pause the video and tell me if the second one you think is the same thing. Okay, we're back. So hopefully you know that the second thing, see how if her hair is wet, that's still our hypothesis. So if my hair is wet, then I showered. Still got the hypothesis, still got the conclusion. Great. All right, but now read this one. Pause the video and think about how this is different. So here, see what happened? Here is my hypothesis. So this is now my P, and this is my Q. So while before I had, if my hair is wet, then I showered. Now I've got, if I've showered, sorry, then I know my hair is wet. See how we just flopped the hypothesis and the conclusion? This is what you call the converse. So the converse of anything is going to be the flip of the hypothesis and the conclusion. All right. So now I want you to, one more thing. If the converse is true, then you know you have a biconditional statement. So if the initial conditional statement is true, right? And I told you that it will always be true. And the converse is true, then you have what is called biconditional statement. And this happens with definitions. And we're going to see a lot of definitions this school year. So an example would be um, if you are playing basketball, then you are bouncing a ball around, running and shooting. I don't know. So if you're bouncing a ball around, running and shooting, then you're playing basketball. That's not the best example, but you know what I'm saying. Another example of this would be if 2x equals 10, then x equals 5. This would be another example of a biconditional statement. So the converse here would be if x equals 5, then 2x equals 10. And is that true? Yes. So that's what we call a biconditional statement. Okay. So this is now logic 2. So we just did logic 1, which is the basic stuff about conditional statements. Logic 2 is all about just simplifying things into symbols. And I've already kind of done this for you without explicitly talking about it. So remember, this little arrow means implies. This little like inye means not. This guy means and. And if that means and, what do you think the last one means? Or. Right. So the way to remember and or is see how it looks like a little a? Good. Okay. So I want you to pause the video here and try to translate this using symbols. Now be careful. Watch where the hypothesis and the conclusion are. Go. All right, we're back. Look at how cute little baby Zoe is. I think that was her first day at the carriage house in 2018. She was like 4 months old. All right, so hopefully your translation looks like this. So when she got pepper in the nose, that's your hypothesis. And she didn't sneeze would be not S. Cool? So if she got pepper in her nose, then she didn't sneeze. All right. So now I'm going to give you a bunch of different things, and now you're going to kind of do the reverse. So given that A means I'm hungry, B means I make a sandwich, and C means I'm happy, I want you to pause the video and go ahead and translate these into words. All right, we're back. Now I want you to take a peek at this. So here are all of my translations. So my first one is if I'm hungry, then I'm sorry, if I make a sandwich, then I'm happy. So that's a pretty straightforward one. The next ones get a little bit more complicated. So if I'm hungry and I make a sandwich, then I'm happy. The third one is if I'm happy, then I'm not hungry. So remember that little inye means not. The next one is if I'm hungry, so that A, or if I'm happy, then I'm going to make a sandwich. So those are two ways I celebrate being hungry or happy. And the last one is if I'm happy, then I'm not hungry. And if I'm not hungry, then I won't make a sandwich. How'd you do on that? All right, so go ahead and tackle both worksheets, Logic 1 and Logic 2, and we will see each other soon. Thanks.